1. So what you're going to do, I was like, what is that? Okay, so first thing, match, do your matching, Okay, so this point right here, you're going to plug into this, and then you're going to draw a line segment with the slope that you get when you plug into that. So for example, I'm going to start here. Every point in this column has an x of 2, right? 2, 0, 2, 1, 2, 2, etc. But I only need to plug in the x. So what's 2 minus 1? 1. So these are all going to have a slope of 1. Then I'm going to move over. What's every x in this column? 1. Then I plug in 1 minus 1. What do I get? Slope of 0. So those are all going to be flat. Okay, then I'm going to move over one more. This is x equals 0. What's 0 minus 1? Negative 1. Move over one more. Negative 1 minus 1. What would that be? Minus 1. Negative 1 minus 1 more would be negative 2. So my slopes should still be negative, but they should be steeper. And then if I go back one more, negative 2 minus 1 is negative 3, which means they should still be negative, but even a little bit more steep. So like this. Okay? Let's go down to the next one. So the next one, I'm plugging in x squared. So let's start here. 2, if I square it, what do I get? Slope of 4. So that's going to be pretty steep. Now let's go back one to x equals 1. Plugging into here, what's 1 squared? Still 1, so it will be diagonals. Okay, then come to the middle. What's x in the middle? I think you're looking at the...
Columns is up and down, okay?
Yeah, I'm looking at...
Oh, wait, that's like you.
Oh, yours is the same. The point is just here. I forgot. I have a different version, but it's the same thing. Okay, so then from there, this is 0. What's 0 squared? So these should all be flat. Okay, then come over here to negative 1. If I square it, what do I get? Positive 1. So what that means is that these two rows should kind of match each other. And then if I plug in negative 2 squared, I'd get 4, which would be like that. Okay, will y'all work, please? Okay, now, the other thing that you should know from yesterday is that when you solve the differential equation, you're going to get this shape. So, let's integrate on both sides. What's the integral of dy dx?
1/2 x squared.
Okay, just this side, there will be a y.
Oh, yeah.
But you're right on the other side. So on this side, the integral of dy dx is y. The integral over here on the x would be 1/2 x squared. And then minus that would be a 1x plus c. What shape is that if it's an x squared graph?
It's
It would be a parabola. And do you see how the slope field that we drew is kind of like a parabola shape? Now, the point that they gave you, 1, negative 1, I would just have to hit that point and then draw in the graph from there. So now let's do number 2. Okay, dy dx equals x squared. Integrate on both sides. What's the integral of dy dx?
1 minus 3. So this is a higher.
Close, so you'd increase it to be an x3, but then you'd have a 1/3, right? Okay, and then what shape is a cubic graph? Do you remember? It's the one that looks like this. And if I connect my dots through 0, 0, because that's the point they gave me, I can see that I'm graphing the cubic parent function. Does that make sense?
3 minus 4 is negative 1.
Yeah, so you'd be just kind of following the direction. So it's not like you have to hit a specific point. You're just kind of sketching that shape. Okay? So the other thing we learned yesterday is that if you have slope fields that have an x in them, the pattern you notice is that you're going to have columns. So if it has only an x, your slope field is going to have columns. Okay, now turn over to the next page. And instead of your equation having x's in it, it's going to have y's in it, okay? So like everything in this column, this slope is the same. Everything is the same. Everything is the same. So the next one we're going to do, you're going to notice the pattern is across the slope. Okay, and here's why. Okay, let's say now y'all's on this one, I think the dots go higher. Do they or no? No? Okay, cool. So if I plug in everything on this line, what's my y?
Y3?
2, because this is 0. So 0, 1, 2, yeah? What's 2 minus 2? So all of these would be flat. Then I'd go down 1. What does every point in this row have? They all have a 1. So if I plug in 1 minus 2, I get negative 1. What about if I go down to 0? What's 0 minus 2? Negative 2. What if I go down 1 more? I'd have negative 1 minus 2 more, which would be negative 3. So it should be a little bit steeper. And then if I go down 1 more, it should get even steeper than that. Get the idea?
Next one, it'll be.
So as I go down, my graph is just getting steeper each row. Good? Okay, let's go down to the next one. So, and actually, let's solve this, but to make it easier, so we are going to have to separate this. So do you remember how, like, you can't integrate y stuff on this side? So I would have to take my y minus 2 and make it a 1 over y minus 2. Do you remember that?
Yeah.
And then you'd have like a 1 dx. You have to leave something on x's side, so I would just leave it x. Okay, then if I integrate on both sides, the integral of 1 over u, what is it? ln, so this is going to be ln y minus 2.
It'll be 1/2, and that's 1/2.
Then what's the integral of 1? X plus c. Then what would I do next?
Move the x.
Well, I'd e both sides and then move the x, yeah. So I'd have y minus 2 equals c e to the x. You move the c down. And then what would I do with the minus 2?
Oh, wait.
Good. So it'd be a plus 2 at the back. So that's your general solution. You don't have to, because the c in the front, you already don't know what c is. So that's why it doesn't matter. Okay, now let's draw the particular solution through 0, 1. So 0, 1 is here. And then as I approach 2, my graph needs to get closer and closer to flat. And as I go this way, my graph is getting steeper and steeper. Now, think about what the e to the x graph usually looks like. Usually, e to the x is the exponential growth graph. But because I'm on the bottom, it's like an exponential growth graph, but that got reflected. And does it make sense why if I have a plus 2 here? Do you remember how that moves the asymptote from like pre-cal and algebra and stuff? So this is an exponential growth graph that's shifted up 2, but then because I'm below the axis, it's reflected down. It is, and if we solve for this point, it comes up. So let's do it and then we'll see. So let's plug in that point. So if 1 is the answer when I plug in 0, well then e to the 0 is just going to cross out. C plus 2 is 1, then what do I get for my c? I would minus 2, and c is negative 1, which means that my equation for my graph is y equals negative 1 e to the x plus 2. And so what you said, Alina, is exactly right, that because I have this negative, that's what tells me that I took my exponential growth graph, I shifted it up 2, and then I reflected it upside down. Does that make sense? Okay, so now look at your matching sheet that we're doing for today. So if I'm looking for, let's do this one first. So 3 minus x, what will make it, first of all, rows or columns, if it has an x? Columns. And then what will make this 0? So look on your slope field sheet. When at 3 do you have all flats?
F10.
It is 10, good. Okay, so at 10, see how these are all flat?
Yeah.
Okay, now let's pick a second point besides 3. What if I pick 2? Plug in 2 to that equation. What is 3 minus 2? Yeah,
It's 1, so
it
it's
would
2.
be 1. And at 2, do I see slopes of 1? Then that's another point that I know for sure that's right. Does that make sense? So on my sheet, I would say graph number 10 matches this one. Okay, let's do another one that's easy. Let's do this one. This is rows or columns? Rows, what will make it 0? 2 minus 2. So look for a row at 2 of all flats. They have to all be flat across though. Now that has a flat spot, where is it? 1, 2, 3, 4. White. Flat at 2. So slope field 2 is this one. Okay, now look at the one right above it between these. What 2 y's will make this 0? When y is
For some reason I don't.
0, or what about this one?
Okay, so we'll start out 1.
4, because what's 4 minus 4?
Plus 1 is 2. That is not
0.
0.
Yeah.
It's not.
So I'm looking for y equals 0 and 4 to be flat. So look on your graph, where's that going to happen?
7.
7. Do you see how you have all your flats here? And then you have all your flats here. Now also, if it's on the x-axis, a lot of times the flats don't really show up. But you can see that it's getting flatter each time. That's where it would have been flat. So I have all of my flats here at 4, and then I have all my flats here at 4 and at 0. Does that make sense?
Yeah.
Okay, so we have that one is SF.
X over Y.
Okay, let's build to that. So let's finish out the rest of them because then you'll only have a couple left. Okay, so for regular X, do I want a row or a column? Column of what? X equals what will make it flat? 0. So which one is flat all the way down the middle? Okay, 6 is, but those aren't columns. Because look at my columns. Do you see how they're not the same every time? So that can't be a column. That's a mix where they're mixed, where I have X's and Y's. So we can't pick that. Where else is it flat, straight down the middle?
No, it's 1.
Okay, but here I don't have columns again. See how these are changing? So it has to be a column with an X at 0. So it would be 1. Very good. See how these are all the same? And then when I move over 1, what are all my X's here? 1. And if I plugged it in, I have a slope of 1. What about here? I have a slope of 2, then 3, etc. Does that make sense? Also, when my X's are on the left side, they're negative, but what's my slope? Also negative. So SF1 goes here. Okay, what about y over 2? What will make that 0 if y is 0? So look on your graph. Where do I have flats only at y equals 0? So basically the x-axis should be your only flats. Number 4 is correct. So that would be number 4. Okay, so now let's get into the other ones where it's x and y. So for this one, what would x and y have to be so that they add to 0? Okay, 0, 0, but what else? What other
Or a
points?
negative and a positive.
Negative and a positive of the same number.
I think if 4 and 1 are switched, because
No, because 4 should be rows, so it has to be a y.
yeah, so we did.
So these are rows that are the same, so it has to be y in your equation because they're rows. Okay. When you're ready to check, okay, listen. When you're ready to check, the answers are right here. Okay. Come look when you're ready. Okay, so x plus y, they need to be opposites. So out of my graphs that are left, we did this one, we did this one, we did this one, we did this one. Okay, so out of the ones that are left, where are x and y opposites that I have zeros? Okay, so let's look at this graph. I see flats all right here. What ordered pairs are these? 1, 1, 2, 2, 3, 3. Do those add to 0? No. Let's do this one. I see all my flats. Okay, careful though. What's this? 1, negative 1. 2, negative 2. 3, negative 3. Will those add to 0? Then that's going to be dy dx is x plus y. Because when I add those coordinates, I would get flats. Also think about, what if I picked a point up here? That's 3, 2. What's 3 plus 2? Positive slope. Pretty steep, that's a 5. Does that make sense? And then as I go up, my graph is getting steeper because I'm adding bigger numbers. Does that make sense? Okay, now next one. We want x minus y and y minus x. What do your x and y have to be so they subtract to 0? They have to be the exact same number. So look at our graph here. Remember how these were the same every time? But also,
Here's the second page.
so now I have to pick. Do I want x minus y or do I want y minus x? So what you do at that point is you're going to pick a test point, plug it into both, see which one it matches for. So let's pick negative 1, 1. This one, negative 1 is negative. This one, it comes out positive. So then I'll plug that point into both of these and see which one matches. So if I plug in negative 1, 1, what is negative 1 minus 1, 1? Negative 2. Then this has to be this one. Versus what if I plug in negative 1, 1 here? I have 1 minus negative 1, which matches the slope.
Okay, we're gonna share it.
Does that make sense?
Okay,
So then on my sheet now, I know that this was slope field 8, right? This was 3. And then what was this one? 5. Okay, so we have 2 more left. We're dividing x and y. Okay, and our only 2 choices left are these 2. So let's pick a test point, divide them, and see if it matches. So our choices are x over y or negative x over y. Let's pick 1, 1.
basically. Well, no, because these are.
If I plug in 1, 1,
Yeah.
what's 1 divided by 1?
Like, when these are
Is
positive.
that a positive slope as well? No, and it has to be.
Negative.
And if I plug in 1, 1 to this,
Okay,
it
so
will
let's
come out negative to match that. Does that make sense? So then that would have to be 9 and 6, like that. Yeah, I said them backwards. Okay, look up. Check your answers. Oh, you're not, okay, don't look.
Well, I already saw the last 2 answers.
Okay, well,
So I'm gonna do.
okay, the next thing I want you to do if you're finished,
So this is 1/2.
okay, we will work through the conclusions together, but now rip that page off. You have an entire page full of different conclusions. Each of these conclusions goes with a graph. So, for example, the solutions are parabolas that open up. Which slope field is shaping that shape? Okay, or the solutions are circles. Look and see if I connect the dots, which slope field is going to draw a bunch of circles. Okay? So that's your next step after you're done with the graphs, is to look at the conclusions.
Wait, so I'm ripping off again?
And look at the page now below that. So now you're trying to match these conclusions with the graphs. Okay?
We made our own conclusion.
Oh, okay.
0 slope at x minus 3.
Oh, okay. Are we ready to do it together or no?
Yes. I'm
Yes.
done with this.
Okay. All right, ready?
Hold up, I need to erase this stuff.
You can just squeeze the letter in next
No,
to
I
it.
don't want to.
Okay.
I was already halfway erased.
Perfect. Okay. Okay, so,
Recording.
yes I am. Okay, okay, look at your graphs. Which graph has solutions that are parabolas that open up?
Except one.
SF1, because when I connect the dots, okay, what shape did that make? A parabola that opens up. So what I'm going to do is conclusion 1, I'm going to write next to slope field 1. Got it? Okay, the next conclusion, so I'm going to put a little check here. I found conclusion 1. Next, I want to know which one has circles.
9.
Okay, it is 9. Let's come down to 9. See the circle? Okay, so many circles. Okay, so next to slope field 9,
2.
I'm going to write conclusion 2. So look, I find slope field 9, it's here. I'm going to put conclusion 2. Okay? Next one, I'm checking off conclusion 2. Where did I have a horizontal asymptote? Okay, that means flat slopes only at 0.
6 and 4.
Okay, so let's see. Only at y equals 0. So if I look at SF6, okay, these aren't flat, these are blank. Remember, that means you have an undefined slope. Okay, remember that when they're blank, that means it's undefined. But I am going to choose SF4. Okay, and I know that on these copies off the digital thing you can't tell, but on the AP test they'll put like little tiny lines right on top of it where you can see it better. Okay, so slope field 4 goes with conclusion number 3. Okay, next one, I want 2 horizontal slopes at 0 and also at 4. Which graph, okay, good, 7, has 2 horizontal slopes? So I'm going to write conclusion 4 next to slope field 7. Does that make sense? Okay, so here's slope field 7. Conclusion 4 went with that. Get it?
Thank you.
Okay, do you think you can finish it?
Yeah.
Now, do you remember what a hyperbola is?
No.
Okay, draw in like this. A hyperbola is this one. Okay, remember that a hyperbola, you would only have either the vertical 2 or the side 2. You should learn that in Algebra 2, but I know it's been a while. So hyperbolas are the ones where it's like matchy parabolas that open away from each other. It's SF what? 6. So then on my sheet next to 6, I'm going to put conclusion 5. Okay? Okay, parabolas that open down. Did you find it? Okay, SF10. Very good. Those are your parabolas that open down. So next to slope field 10, I'll put conclusion 6. Now, read the next one. It says, the limit as x goes to infinity. What is that the definition of? Yes, what kind of asymptote? Okay, that is a horizontal asymptote. That's another way of saying it. So which of your graphs had a horizontal asymptote at 2? Okay, graph number 2. So I would say this one is conclusion number 7. Okay, we have 3 left. I'm going to show you how to do one, then you're going to do the other ones. Okay, if I want my solution to be a line, you're going to look for the line in the slope field. Okay, so I'm going to look at slope field number 3. Do you see where it's linear?
No.
Okay, right here. Okay, that is my linear solution. And then I'm just going to write the equation of that line. So, first question, where is its y-intercept? -1, and then what's its slope? So that's y equals 1x minus 1. Which conclusion matches the correct linear equation? Y equals x minus 1. C9. Very good. See how they match? Okay, also, do I go through 0, 1? Yes. Okay, so C9 is a match for slope field 3. So next to 3, I'll put 9. Okay, 2 more. Do the last 2. Now you like it? Now is it easier? I don't like that. Thank you so much. Thank you so much.
I'm just tired today. I couldn't take a nap in my last period.
Oh my gosh. Nap at home.
I don't sleep good. Melatonin. Okay, that won't even help. I don't breathe when I'm sleeping.
What?
You have a CPAP? No, I don't have sleep apnea. I have what's called like your, you are URS.
Okay, so this one has a downhill slope. Which conclusion had a negative slope?
8.
C8. So 5 goes with 8. And then that means that the other one has to be 10. Yeah? Okay, last thing we're going to do in this chart, you're going to say yes or no if the equation is separable. What that means is that you could solve it. Okay, what can you separate based on? What two operations? Plus, minus, times, divide. Which ones? Times and divide. If it's plus or minus, you cannot separate. So put a check for yes or a Y. Put an N for no. Go down each one. Okay, I'll also give you a hint that if it's only X or only Y, it's automatically separable because you only have one of the letters. So several of those should automatically be yeses because they have only an X or only a
So
Y.
if it's X plus Y, it's not.
Correct.
So basically,
Okay, all of the top ones are basically separable because they have only X or only Y. What about X plus Y? What about X minus Y? Y minus X? X divide by Y? Yes. What about negative X divided by Y? Yes. Okay.
wait, why is 3 minus X separable?
Because X is already on its own side. So think about, could I integrate that as is? Yeah.
Oh.
What's the integral of dy dx? Y. What's the integral of 3x minus a half x squared plus c? That means I can do it. Does that make sense? You only have to separate if it has x's and y's together.
I don't know why I thought like when you were saying like separable, like they're
Okay, take a look for me now, please. Flip over to the back side
of what? Oh.
of your now the other papers, you can keep them or not. Okay. Let's do number 3. Write an equation of the line tangent to the curve. What two things do you need? Okay, what do I have? What do I need? So I'll do dy dx at 2, 9. Okay, y is 9, so it'd be 9 over 2. This is the back side of that front chart. Flip over the chart page. Nope, yep. Okay, which is 4.5. Then I'm ready to write the equation, the tangent line, y minus 9, 4.5, x minus 2, done. Okay, if they gave you a number to plug in, you would do it, but they don't. Part B, how do I find a particular solution? Separate. Okay, so I have dy dx equals y over 2. What has to move? The 2 is chilling. What has to move? The y. And if y is on the top, now it's a 1 over y. But my 2 is now a 1 over 2 dx. Okay, remember, I can leave the 2 there, but I have to leave a 1 as a placeholder. Okay, then from there, I'll integrate both sides. Okay, what's the integral of 1 over y? ln absolute value y. What's the integral of a half? Half x plus c. Then how do I get rid of the ln? E both sides, so I have y equals ce to the 1/2 x. Okay, then you have your 0.6 comma 8. Could you solve that? Okay, we're not going to do it. Go to the next one. Okay, it says there's a horizontal line that satisfies the differential equation. Horizontal means what slope do I want? Yeah, so 0 slope. What will make this 0? That's all it's asking. 2. Okay, because if I plug in a 2 to this, it's going to give me a 0 slope. Okay, do you know how to separate that? You divide it. So you'd have 1 over 2 minus y dy. And then what would I leave on the x's side? Because I just literally took everything across. Times 1, and I'll leave the 1. I cannot leave the 2 because y and 2 are connected by addition or subtraction. You cannot add or subtract y across. So I'll keep this as multiplied by 1. I'll divide that to the bottom, and I'll leave a 1 dx. Then integral. What method will you need here? So your u is 2 minus y. What's your du? Negative 1 dy. Which means that dy is du over negative 1. Then from there, I'll rewrite my integral and continue solving. So that's now a 1 over u du, but my du is over a negative 1. And what's the integral of 1 over u? ln u, but I'll just keep my negative in the front. So this is negative ln 2 minus y. What is the integral of 1 on the other side? 1x plus c. And can I e both sides immediately with that negative where it is? No. So you'll have to multiply everything by negative 1 and then e both sides. So you'll have ln 2 minus y, negative x plus c. Why do I not change the c? You didn't know what it was anyway, so you don't care yet. Okay, e both sides. 2 minus y, c e to the negative x. What would I do next? Subtract the 2 across. And then for my last step, that's a negative 1, I'm going to have to change the signs. What do I not change the sign on? C. You don't care that it's a negative c now, but you do care that that 2 is a plus 2. And then from there, you take your point and sub it in. You get it?
Yes.
Okay, good job. You have like 1 minute, so. Okay, we are going to work next week if you were hoping for a free day. Bad news. Huh?